Hello, this is Dr. Strickland. In this video, we will complete our investigation of the nomenclature of alkenes. Take a minute to read through these student learning objectives. These are the things you should be able to do by the end of this video so that you're ready for the more difficult things we will do together in class. So we're going to look at some examples of doing the name of a structure and then drawing a structure from a name. We're going to use the rules that we talked about with naming alkenes and combine them with what you already know about determining the E and Z configuration of carbon-carbon double bonds. So you know that whenever you're going to name an organic compound, first thing you do is find the parent and number it. So we're looking for the longest continuous carbon chain that contains the group of highest priority, which in this case will be the carbon-carbon double bond. So that means we're going to give the two sp2 carbons the lowest possible numbers because we don't have any functional groups of higher priority. And so you can see that this is a 1-pentene. So I'm going to build this name from right to left. All right, and the 1 tells you where to find this. Okay, so what else is attached to this? Well, there's a fluorine at carbon 2 and a bromine at carbon 1. B comes before F, so it's 1 bromo, 2 fluoro. So let's put those substituents in. So we did the parent, the substituents, and then the stereochemistry comes at the very front of the name. So we got to know whether this is an E or a Z isomer. We can't use cis and trans because this carbon doesn't have a hydrogen on it. This sp2 carbon does, but the one on the right does not. So we need to find the group of highest priority over here on the left, and then the group of highest priority of the things over here on the right. Okay, so these are the Coningal-Prelog rules. And so bromine has a higher atomic number than hydrogen, so this is a higher priority. Fluorine has a higher nomenclature priority than carbon, so this has a higher priority. The two things of higher priority are on the same side, and that makes this Z. So I would recommend that as a strategy for naming in general. You know, do the parent, do the stuff that's attached to it, do the stereochemistry. So if we try this kind of strategy over here, where you start with the name, I would start with this much. And I'm just going to do a sketch up here at the top. So 1, 2, 3, 4, 5, 6. This is not a final structure by any means. Okay, so I'm just going to stick my numbers in here. I know that it's a 2-hexene. That means the carbon-carbon double bond is between carbons 2 and 3. And then what else do I know about this? Well, there's an isopropyl group on carbon 3. There are 2 fluorines, one on carbon 2, one on carbon 1. And remember, the two-dimensional structures tell you nothing about stereochemistry. I know that this double bond here is going to have the E configuration. And then we need to have the rest of the hydrogens in here. So this carbon needs 2 of them to get up to 4 bonds. This carbon already has 4 bonds. All right, so let's say this one needs, does this one need anything? 1, 2, 3, 4, nope. This one needs 2. This one needs 2. This one needs 3. Okay, so I would look at the sp2 carbon on the left first. So I've got this and this. And which one of those two has the higher priority? There's a fluorine and a carbon, so it's this one, it's the fluorine. So it's tempting to think that the group that has more atoms will have the higher priority, but that's not always true, because the first thing you have to look at is the atomic number of the 2 atoms that are directly bonded to that carbon. All right, so this is the sketch. Okay, this is not the final structure. The final structure has to show this E stereochemistry. So I've got to draw those bond angles like this. So I'm just going to decide to put the fluorine there. And that puts my CH2F right there. Okay, so here they are. And this one had the higher priority. Okay, so that means with E, I've got to have the two groups of higher priority on opposite sides. So the other one has to be down here. Okay, so let's look, see what we've got attached to this sp2 carbon. Well, we've got an isopropyl group, and we've got this regular propyl group. Okay, so this two carbons, this is a carbon, hydrogen, hydrogen, moving away from the sp2 carbon. And this is a carbon, carbon, hydrogen. Okay, so that tells me that the isopropyl group has the higher priority, and that means that the isopropyl group has to go right here. And then the rest of it goes right there. Okay. All right, so this is the final structure. And if you're doing a sketch, you know, like with on an exam and you want to do a sketch and then a final structure, it needs to be labeled final structure, because on an exam, 2 answers equals no answer. Okay, it's not, you can't do this as multiple choice for me. So make sure that it's labeled so that I know. All right, so what if you have more than one carbon-carbon double bond? Well, they both have to be part of the parent. So we're going to do that, and then number it so that the alkenes get the lowest possible numbers. The 7 carbons would be heptane. 1 carbon-carbon double bond would be heptene, and so 2 is heptadiene. And the numbers will be the lower of these two and the lower of these two. So this is 1, 3 heptadiene. And now we need to know about stereochemistry. Now, does this one have stereochemistry? Do we need to decide whether it's E or Z? No, because there are 2 hydrogens on this sp2 carbon, so we don't do anything there. But this one we do. So, I'm going to look at the 2 things that are attached to this carbon here. There's a hydrogen there. And then the 2 things that are attached here, there's also a hydrogen there. So we've got this, and we've got this attached to the sp2 carbon on the left. This is the higher priority. We look at the ones on the right. We've got this, and we've got this. This has the higher priority. So this is what? All right, I want you to put the stereochemistry right in there. Pause the video, write down whether it's E or Z, and then come on back. Okay, welcome back. So since the 2 groups of higher priority are on opposite sides of this line right here, this has to be E. And since there's only one of these double bonds that needs to have stereochemistry, it doesn't need a number. Once you have more than one that has to be E or Z, just like with R and S, then the number has to be paired with the designation for the stereochemistry. All right, come on over here with this one. 2Z, 4Z, 1 chloro, 2,4 heptadiene. Okay, let's do the same sort of strategy. 7 carbons. 1, 2, 3, 4, 5, 6, 7. Okay, we'll give them some numbers. Two, 4 heptadiene, that's between 2 and 3, and between 4 and 5. and then one chloro. Okay, so we know that this one has to be Z, and this one has to be Z. Let's put the hydrogens in and we can get started with that. So 2 hydrogens there, 1 here. This guy has 1, 2, 3 bonds, so 1 there. This guy has 1, 2, 3 bonds there. Same thing here, here, and here. Okay, so this is the sketch. So I'm going to start from the left. You don't have to. You can start from the right if you want to. But I'm going to build it like this. All right, so when you look at 2 things that are bonded to the left-hand sp2 carbon here, this is the one of higher priority. So I'm just going to put it up here. So the hydrogen goes there. If I want this to have the Z configuration, then the 2 groups of higher priority have to be on the same side. So if you look at what's attached to the right-hand sp2 carbon, there's a hydrogen and the rest of this. So the hydrogen is going to go down here so that the rest of the molecule goes up here. So we've got a carbon there, but this carbon is itself involved in a carbon-carbon double bond. Okay. It also is Z because this is 1, 2, 3, 4, 5. So let's see. Let's put some numbers on here. Maybe that'll help keep track of things. I think half of chemistry is just keeping track. All right, so when we look here, carbon 4 has the hydrogen here. So from the perspective of carbon 4, it's attached to this hydrogen and all the rest of this. So this is the group of higher priority with regard to that. And with carbon 5, it's the hydrogen and the ethyl piece. So the ethyl piece goes here, the hydrogen goes there. Now, if you've got 2 hydrogens on the 2 carbons of the double bond, you know, for Z, you know that the 2 groups of higher priority have to be on the same side. Well, that means the 2 groups of lower priority have to be on the same side. And so I think it's easier for me to track the hydrogens in both of those cases. But that is how I would put it together. All right, remember to label what your final structure is so there's no question. All right, so what if you have a cyclic alkene? Okay, so a cyclic alkene is a cyclic hydrocarbon in which 2 of the ring carbons are sp2 hybridized and joined by a carbon-carbon double bond. A number is not needed to denote the position of the functional group because it's always between carbon 1 and carbon 2. So like in this case, these 2 would have to be 1 and 2. I'm going to choose to do it this way because then if I do it this way, then the methyl groups are on carbons 1 and 3 rather than on 2 and 5. Okay. And you don't do any stereochemistry on rings that are smaller than 8 carbons. So same way, I'm going to do the parent first, cyclopentene. As long as the alkene is the group of highest priority, then these 2 carbons have to be the ones that get the lowest possible numbers, and that's why it would have to be a 1-ene rather than anything else. All right, so what else do we have attached to it? Well, we've got those 2 methyl groups at carbons 1 and 3. So 1,3 dimethyl. Each methyl group gets its own number, and the die tells you that there are 2 of them. So no stereochemistry. On rings with fewer than 8 carbons. Okay, if you had a cyclooctene, you'd have to tell me whether it was cis or trans, E and Z. But we don't have to do that today. All right, so come on over here. If we've got 5-sec-butyl 3-ethyl cyclohexene, there's the parent. And you can put that double bond wherever you want. Let's say we put it here. And so, you know, when you are drawing from a name, you are the captain of the ship. And so you can decide where you want to put the double bond and that dictates where the numbers go. And then you just attach everything else. 3-ethyl, right there, 5-sec-butyl. All right, so you have to know the difference between those different branched butyl groups. Okay, that would look like this. Okay. All right. Now, we're going to begin talking about polyfunctional molecules, and we'll have much more to say about this in later chapters, but I wanted you to just begin thinking about them. If you have something like this, you know, anytime you have an ether, an acyclic ether, you've got to decide whether the right side or the left side is the parent. If one side has a group of higher priority, it has to be the parent, even if it has fewer carbons. So this is actually 1, 2, 3. And this is a substituent on this parent. So the parent is 1-propene. And what's attached to it? Well, let's see, 1, 2, 3, 4, 5. So this is a pentoxy group attached to carbon 3, so 3-pentoxy. You always have a hyphen between a letter and a number to a letter. And so, you know, with acyclic alkenes, very often you have to do E or Z or cis or trans, but in this case, we've got 2 hydrogens on this terminal carbon, so there's no stereochemistry to do. All right, so what about this one? This is a really fancy one. So, I want you to take a look at this. Now we've got a situation where the 2 carbons of the carbon-carbon double bond are not the group of highest priority. The alcohol is. So let's see how this plays out. We've got 6 carbons. So let's do a sketch. All right, so what do we know? Well, we know that it's a 2-hexene. That tells me that the carbon-carbon double bond is between carbons 2 and 3. Need one more. There we go. A great value in numbering them, right? See? Figure out when you've forgotten one. All right, so that goes there. The 1 tells you where the alcohol is. All right, let's see what we got. 6-bromo, 2-ethyl, 3-methyl. 6-bromo, 2-ethyl, 3-methyl. All right, so we know that this guy is going to have to be E. And let's fill in the hydrogens. All right, this carbon currently has 2 bonds, so it'll need 2 hydrogens. This one already has 4. This one already has 4. They're good. This one has 2, so it needs 2 hydrogens. This has 2, needs 2 hydrogens, and this one as well. All right, so let's see. Let's emphasize the carbon-carbon double bond because I think that's the easiest way to show E and Z. I would do it that way. If you want to do it with a skeletal structure, you know, we can talk about how to make that happen. All right, so let's take a look. We've got this and this. This one is the group of higher priority because even though this carbon is bonded to 2 carbons, this one is an oxygen, hydrogen, hydrogen. This one is a carbon, hydrogen, hydrogen. So let's put the group of higher priority up here. And we'll put the ethyl group down here. And as long as you show, you know, the bond to the correct carbon, you can do it. You can put the rest of it out to the right like this, or you can put the rest of it out to the left like that. And either is fine. Okay, so what about the other side? Well, same sort of thing. We've got a methyl group attached, and we've got all this stuff. and it's got to be E. So the two groups of higher priority need to be on opposite sides. So the methyl group is the lower priority because this carbon is attached to 3 hydrogens. This one is a carbon and 2 hydrogens. It really has nothing to do with the bromine out there. But so let's put that down here. Structure. All right. So that is the basic story on the nomenclature of alkenes. If you have any questions, please send them to me.